Hello, I'm Ho-Jun Lee, and today's title is To Find Pathogenic Variants Related to NF1 Disease. In our previous video, I showed how I called genomic variants in our NF1 patient. Among 5 million variants, we searched for potential NF1 causing variants. We focused on three key properties: pathogenicity, rarity, and disease relevance. For pathogenicity, we used the ClinVar database for short variants and NF1 program for structural variants. For rarity, we checked the NOMAD database frequencies for short variants and 8 databases through NF1 for structural variants. To determine disease relevance, we needed to establish a set of NF1-related genes. Next slide will explain how we got the set of NF1-related genes. To find NF1 disease-related genes, we used three different criteria. First, we included NF1 gene, which is primarily known to cause the disease. Then, we added genes involved in the NF1 pathway, specifically the RAS-MAPK signaling pathway. In the pathway, there were 18 genes near NF1. Finally, we incorporated NF1-related genes identified from the Disease 2.0 database. The database performed text mining to get disease-related genes, and we got 85 genes from the database. 72 genes came exclusively from the Disease 2.0 database, while 12 genes were shared between the pathway genes and genes from the database. Our approach using these three criteria resulted in 90 genes total. We used these genes to evaluate the variant's relevance to the NF1 disease. Next part is SMV or indirect filtering process. We started with nearly 5 million variants and applied the three sequential filters. First, using ClinVar annotations, we identified variants classified as VUS or variants of uncertain significance, likely pathogenic or pathogenic, which reduced our candidates to 80 variants. Then we filtered for rare variants with a NOMAD allele frequency below 0.05, leaving us with 24 variants. Finally, we focused on variants in the NF1-related genes, which led us to identify just one NF1 causing variant. Next, we applied the same filtering strategy to structural variants. Starting with over 22,000 SV, we first filtered for variants classified as VUS, likely pathogenic, or unclassified by NF1, which gave us about 16,000 variants. After applying the allele frequency filter of less than 0.05, we found 177 variants. However, when we looked for variants in the NF1-related genes, none remained. This made me curious, so we tried an alternative approach. What if we skip the allele frequency filter? This identified 6 variants in NF1-related genes, shown in this table. However, looking at their allele frequencies, which range from 0.16 to 0.98, these variants are too common to be rare disease causing. Therefore, we concluded that there were no NF1 causing structural variants in our patient. In conclusion, our comprehensive analysis of nearly 5 million SMV or indirect variants and over 22,000 structural variants led us to identify just one SMV that is pathogenic for NF1 disease. The molecular effect of the variant is explained in previous videos. This is the end of this video. Next time, I will present the quality control steps in our NF1 data. Thank you for your attention.